Welcome pre-calc students to your first flipped classroom. Sorry I'm not able to be there today. I have two sick kids at home, but I wanted to make sure I had an opportunity to try to help explain logs to you. So let's see if I can figure this out. This is where we're going to be starting today. We're going to be doing properties of logarithms. So as we're here, what we're going to work on is how do you find the inverse of a function. So right now, go ahead and pause this video and find the inverse of each of these. Don't forget to find an inverse. You flip x and y and then solve for y. So go ahead and do that. All right, as you guys come back on, you should have done x equals 3y plus 1. You get x minus 1 equals 3y, and x minus 1 over 3 equals y, and we're going to call that y inverse. So that is the inverse, and don't forget that for inverses, the domain and ranges switch. For this function, you would have x equals y cubed plus 5. You'd get x, that should be a minus 5, equals y cubed, or the cubed root of x minus 5 is equal to y, and we'll call that inverse. So we see that whenever we have, say, multiplication or addition in a problem, you're able to find inverses, or in this problem, say, when it's raising it to a power and adding 5, you're able to find inverse. So here's we look, recap of inverses. If x is the input and y is the output, in the inverse, it's the opposite is true. In other words, basically the domains and ranges flip. So why is it important now when this is information we looked at back in chapter 1? Well, you can see that, addition and subtraction are inverses. Multiplication and division, squaring or square rooting, or in the last problem you saw cubing and cubed rooting. So the question today is, what is the inverse of an exponential? So if we look at an example, a population of bacteria grows according to the formula P equals 10 to the T, where P is the colony size at time T in hours. When will the population be 2,500? Well, we've already talked about how to solve this. You can solve it where you do it graphically and you find the intersection. You can use guess and check, which would take a long time, but you can find it. Where somebody said at some point, we need an inverse. So if we have this formula, 10 to the T equals 2,500, how do you get T alone? And somebody came up with logarithms. So logs, just so you know, are exponents. What you can do is you can take log, and if here, when it was 10 to the T power, 10 is the base. Well, this is set as log base 10 of 2,500 equals T. So log base 10 of 2,500 equals T. And then you can put this in your calculator, and it would give you that T is equal to 3.398 years. So what you can see is that the base, I'm back up here. Oops, I want to make sure I see that T there. The base is written as a subscript for log on the next line. What it equaled on the other side, 10 to the T of 2,500, you get log base 10 of 2,500, and it equals T. And you can see now that your T, which was your exponent, is now isolated. And I always tell students when they're learning this, logs are actually pretty easy. Logs are always equal to exponents. Okay, so the T here was your exponent, so the log equals your exponent. So we're going to spend time today just learning about all different properties of logs. Here is the definition of a log. Log base A of B equals C. Then you have that A is the base, C is the exponent, so A to the C power equals B. And then also, when you have log, and there's no base, that's kind of weird. So log of B equals C. Well, the most common base for logs, or one of the most common, it's not the most common, is 10. There's an imaginary 10 there. So if you see a problem where it's just log of b equals c, it means that that base is 10. So make sure you pay attention. And actually on the last problem, I didn't, when it was, I want to just go backwards, when it was 2500 equals 10 to the t, and we had log base 10 of 2500 equals t, I forgot to say it. When you put it in your calculator, you just write log of 2500 and you would get your answer of about 3.9. So this is how it would go in the calculator. Okay, your calculator only knows base 10, or at least some of the newer calculators can do other bases, but most calculators just do base 10. So it'd be log of 2500 and you'd hit enter and then you'd get your answer. All right, so when we're here, as I just said on the previous screen, one of the most common bases is log base 10. It's truly log base e. So here's what the definition of a natural log is. Natural log of b equals c. Here it's natural log. You don't see the base. It means it's base e. So e to the c power equals b. So this would go for any of the problems that we talk about with exponential growth that are continuous. And anything with continuous growth, we talked about using e in the equation. Well, that means that if you were to find its inverse or solve some of those problems, you would use natural logs. You would never write natural log base e of b equals c. You just don't write that e. It's just you write natural log of b equals c. It's just assumed that if you see the word natural log, that it means it's base e. It is always, always, always base e. And it's the same way. You would never write log base e of b equals c. You just don't do that. You would never write that. You can have log of base anything other than e, because once it's base e, you do natural log of b equals c. Okay. So here's what I want. I want you to take a look at these 7 problems. I want you to pause the video and just rewrite each of them using exponents and then come back on. All right, hopefully you just paused this and found these. And here you can check your answers. And remember, this is the base 10. This is the exponent. Logs equal exponents. So 10 cubed equals 1000. Can I pick a finer point? Let's see if that'll work. Small, no, that's not what I want. Anyways, whatever. Okay, on number 2, it would be 10 to the negative first power equals 0.1. And you should know that because 10 to the negative first power is 1 over 10, which is 0.1. So this was in number 2, some of that work. Here for number 3, you should have that 5 squared equals 25. 5 is your base, 2 is your exponent, 5 to the second is 25. And on this one, it should be 4 cubed equals 64. True statement also. So really 1 through 4, you should be able to mathematically verify that they're equivalent. On this side, you would just have m is the base, t is the exponent, equals k. M to the t equals k. Number 6, again, it's natural log. It's e to the 5th power equals k. And on 7, you would have right here base e. So e to the 3rd equals e to the 3rd. And that's a true statement. So now we're going to work in the reverse. On this page, there are logs. 8 different problems. Oh, I'm sorry. There are exponential problems, exponents, and I want you to rewrite them in logarithmic form. Pause it, and when you're ready, turn it back on and check your work. So this one, if you're coming back on right now, this first one would be log base 7 is 2401 equals 4. Logs equal exponents. And this one is log base 9 of 729 equals 3. 9 cubed equals 729. 3 would be log base 6 of 7776 equals 5. This one would be log base S of G equals H. Number 5 would be log base 5 of 42 equals X. Ooh, 6, I see an E in there, so I'm going to be using natural log, which is base E of 18.4, and it equals X. This one would be natural log, oops, sorry, I'm lying to you. Log, where's the eraser? No, that's not erasing. Let's try that again. There it goes. Okay. Whew. Let's try this again. So, log base 13 of 40 equals X. And this last one would be log base 8 of 14 equals X plus 3. And you can see in every single one of these examples what the logs are equal to or what were originally your exponents. On here, I want you to solve each of these without a calculator. So you should be able to think of it, think how to solve it. So this might take you a couple minutes, but pause the video, go ahead and see if you can come back and solve these. All right, so here you go. This first one, we said if there's no base, it's 10. 10 to what power equals 10,000? Well, 10,000 has 4 zeros, so it's 10 to the 4th equals 10,000. Number 2, this is 1/100th. 10, remember that's a base 10. You don't need to write it. It's assumed 10 to what power is 1/100th, and that'd be the negative 2nd power. Don't forget that this square root of 10 in number 3 is to 10 to the 1/2 power. So it'd be 10 to the 1/2 power equals the square root of 10. 4, 10 to the 1st power equals 10. Number 5, 3 to what power is 27? Well, that would be 3 cubed. 6, 2 to what power is 32? That would be 5. 7 would be 4 squared equals 16. 8 is 5 cubed is 125. So those are all numerical ones that you could actually check or think about as you're going through rewriting it maybe in exponential form. Number 9, it would be n to what power equals n to the 8th, and that would be 8. This one is saying 10 to what power is 0. 10 to any power will never be 0, so there's no solution on that one. Also 11 is saying 10 to what power is going to equal negative 100. Well, 10 to any power is always positive, so again, there's no solution. Number 12 is saying e to what power is equal to e, and that would be 1. 13 is saying e to what power equals e to the k, and that's k. And this one, a lot of people have trouble with this one. It's 10 to what power equals 1, and it's 0. 10 to the 0th power equals 1. So hopefully you did well on those. Really, any of these problems that you're having trouble on, you can let me know tomorrow when I get back, and I'm happy to answer questions. In this one, I just would love for you to pause the video in your notebook, find a blank sheet of paper, and write all these properties. The first two are definition of a log. The next one is basically definition of a log with natural logs. We looked at this, that 10 to the 1st power equals 10. And then here are just number 5, 6, 7, 8 are different properties that you kind of figured out along the way on the last slide. All right, I really wanted to introduce your final exam project. It is on Edmodo, and I would say you might want to open it, and especially now, if you have time in class to finish working on it, it really might be a good opportunity for you to sit and start writing some of these questions. But I will talk about this project for sure tomorrow, but one more day, especially on a block day, you might have some time to work on that. But you can look on Edmodo. I'll try to post that in just a little bit. And then here is your homework. It is page 308 to 309, 1 through 36. There is also a worksheet that the sub would give you, and that should be done now. And the 1 through 36 all in the book should be good. And then finish the stations packet. So this is your homework, and I will see you on Friday.